folks, my name is Ben Davidson, and I'm here on behalf of approximately 175,000 suspicious observers. We are a simple research group, independent of any economic or political strings. Now, I first want to say that human pollution presents an array of health problems: respiratory, endocrine, central nervous system. The flora, fauna, water, and atmosphere of our planet contain poisons, and we put them there. Something in that vein needs to change very soon. Now, that being said, I'll present here an argument for the superiority of an external climate forcing in the current circumstance, supported by current observations and models of the past. It's going to take the form of an interdisciplinary review of changes on the Earth and throughout the solar system. So, we're going to talk about the climate and the sun. The purported consensus on climate change. Always start with a joke, right? Well, there certainly is a consensus regarding a causative element to some degree. However, the point driven home by the Consensus Project should be limited to that scope. The consensus that exists regarding contribution is not found in ultimate causation or in the predictions of what is to come. The U.S. Senate Minority Report. More than 700 international scientists dissent over man-made global warming claims. Now, the use of this document in climate discussions has come under criticism. Why? Because a good portion of those 700 scientists were not previously dedicated to climate research. That's a point I could make for a lot of the IPCC scientists before the IPCC existed. Anyway, I obviously can't show you everybody on the list. However, I would like to point out 3 names, and they are fairly indicative of the caliber of individual we're talking about. Professor from MIT and his field of study, meteorology. A UN IPCC reviewer who could no longer go along with the public story that the IPCC was telling, and a former senior manager at NOAA. The full list contains many individuals with equal or arguably more impressive credentials. That was 2009. Today, if we keep it to just PhDs, this more than 1,000% increase, and mind you, this is just in the United States. Over on the left side of the screen, décolleté Sonne. Does anybody know what this means? It means the cold sun. Very good. The author, Fritz Verenholt, he was considered a green movement pioneer turned heretic, or hero, depending on who funds your research. The disagreement began over observational evidence versus computer modeling, that math that Wall talked about a bit ago. Localized, short-term human effects versus regional and secular variation. And all that argument kind of wound up with speculation abated as 20 years of global warming predictions proved vastly overestimated. Now, recently in a separate work, scientists from NASA, Johns Hopkins, and the Hebrew University of Jerusalem published evidence that the Earth may be able to mitigate human emissions in terms of temperature through natural processes, that the Earth has a way of maintaining its own balance to a degree. Dr. Christie, University of Alabama, Huntsville, he gave us this chart showing the real-world tropical troposphere temperatures in blue and green going back to the 1970s, and we're comparing it with the dominant CO2 models in red. In a quote to CNS News, Dr. Christie said that, on average, predictions were 3 to 4 times what occurred in the real world, with the closest being a Russian model that showed only a 1-degree increase. Now, here is where the sun and CO2 meet, courtesy of our friends at climate.gov. We're going to be looking at this a few times, but let's start with just the bottom 2 panels. First, we have blue and red, global average temperatures in the middle, and at the bottom, carbon dioxide in the atmosphere. And it's tough to see down even below that, but the timeline is as far back as they'll give us, back to 1880. Now, Made a little adjustment here. That vertical line is the time when global warming predictions were made. That CO2 graph down below, kind of going up, that's what the temperature graph above it was supposed to look like. Instead, we're seeing kind of a sine curve that may be about to go back down and look like it probably would be back in the red if we saw farther back into the past. And speaking of the past, the 800-pound gorilla on this page is quite clearly the lack of CO2 data into the past. Now, true enough, the further we go back, the less certain we are of the exact levels of CO2 in the atmosphere. However, our best guess is pretty hard to outright ignore. Because when your best guess about CO2 and temperature going back 350,000 years looks this similar, very, very difficult to ignore the best guess solar CO2 estimation process. Now, forgetting the fact that indeed temperature does appear to lead CO2 in many cases, not the other way around. That's a different discussion for another day. I'd like to point out my little addition to the Vostok ice core data here. Very scientific, it's up there at the top, that tiny little arrow extending the pollution effect. That number from 2007 is actually now well out of date. We're up over 400 parts per million in the atmosphere, and the temperature has not changed much. Well, what caused CO2 to do that? We did. Human emissions. The Industrial Revolution broke that near perfect hundreds of thousands of years of correlation between CO2 and temperature. Now, if you look right at the very edge, it does appear that not too long ago, temperatures may have been even warmer than they are now. So let's take a look at just the last 16,000 years. This appeared in a work by Robert Carter, combining the work of Davidson 2001 and data products using the NSIDC user services. Now, we clearly see warming over the first 1,000 years, but somewhat of a plateau over the last 10,000 years. The yellow portion up top, zoomed in down below. We are seeing a 2,000-year cooling of global temperatures. Now, it may be difficult to see, but there's a little red line right above the E. You guys see the little red line? That's global warming over the last century in its proper context. So, keeping in mind the near perfect correlation that we have through the past between CO2 and temperature, and also keeping in mind that the Industrial Revolution appears to have broken that correlation. And now, with that in the back of your mind, let's look at something that has somehow been criticized, debunked, and trashed as a potential climate factor. Somehow, computer models have turned a blind eye to the sun and to common sense. We're going to see how in a moment, but we're going to start simply with sunspot numbers, one of the most common measures given for solar activity. For some perspective, we have red lines across where the sunspot number is 200, and we have a vertical line in blue when the Earth stopped warming so much. Now, global warming as we know it occurred shortly after that first time up top that sunspot numbers hit the 200 mark on that cycle. Or on the chart, excuse me. That's a mark that was hit the very next cycle down below on the left, and it was hit at least once more before the blue line, and is indeed now tapering downward as the planet doesn't warm as much. If we look on a longer time scale for those sunspots, I'll wait a few seconds to my pointer to get up there. Again, that's global warming up here. As we come down, this is a drop in sunspot numbers as we have this pause in global warming. But back on the left, the Maunder minimum, the last grand solar minimum. That capped off the last mini ice age. But it is important to note that the last mini ice age did last a lot longer than that, began earlier, and due to multiple volcanic eruptions, the solar weakening was but one factor contributing to that extreme cold. So far, we've seen that the CO2 temperature match is nearly perfect over 350,000 years, but it begins to break down when humans begin polluting. Despite the consensus against the concept, the sunspots appear to have a better match from a simple visual point of view. Once again, starting at the left, End of mini ice age. Up at the top, global warming. And as we're coming back down, we have our pause in global warming. Well, what else has been happening since the Earth started warming? One thing is that our magnetosphere, Earth's protective interface with space energy, our planetary shield, has been fading. As shown here in 2 slides, it's an animation from the WDC for geomagnetism in Kyoto, Japan, showing how much our field has weakened. In fact, we know the number is 15% since the 1800s, the mid-1800s. During that time of global warming, when the sunspot numbers were high as they'd been for 400 years, the magnetosphere had been weakening. And while it had been weakening, our magnetic poles had been shifting as well. Magnetic north racing faster and faster over the last 150 years or so across the Arctic Ocean. South pole is moving as well. So that's high solar activity and less protection from it during global warming. Well, let's come back here. Climate.gov, they say you can't use sunspots. You have to use solar irradiance. And they go by the 0.1% variation in solar irradiance over the 11-year solar cycle. Let's see how steady that 0.1% irradiance variation truly is. This shows that exact same data. This is the historical total solar irradiance reconstruction, and this is from the Laboratory for Atmospheric and Space Physics in Colorado. That 0.1% irradiance variation does not seem so insignificant here. It's much harder to see at climate.gov when it's stretched out and flattened, and especially when they don't show you back this far. In fact, to the right side of the blue line is all that we see at climate.gov. We don't get to see the left side and see that the last grand solar minimum is at most another 0.1% away. Context, it continues to be important. Now, one of the questions is, with sunspots dropping now, is irradiance dropping as well? And it was harder to see on that last chart, but luckily, LASP gives us this short-term chart as well, showing the multi-decade drop in magnesium-2 quarter-wing index. This is the irradiance, and it is dropping as well, in addition to the sunspots. We'll read a quote here. A relatively localized, small amplitude solar influence on the upper atmosphere could have an important effect via the nonlinear evolution on atmospheric dynamics on the critical atmospheric processes. The layman's translation, tiny variations on the sun, big changes here on Earth. Of course, you just saw in the previous slides how tiny variations we're talking about. Well, since this planet stopped warming so much, the sunspot numbers have been decreasing significantly during this pause in global warming. These are all points: the lower heliospheric pressure, smaller solar flares, less geoeffective coronal mass ejections. These were all points at the American Geophysical Union's 2013 fall meeting on the weak sun. But I'd like to talk to you about who agrees with this. Craig DeForest of the American Astronomical Society says the current weakness in sunspots is leading to speculation that the solar cycle could be shutting down for a little bit. Mike Lockwood, professor of space environment physics, says the sun is now weakening faster than at any other time in the last 9,000 years. Penn and Livingston of the National Solar Observatory state that a disappearance of the sunspot cycle for multiple cycles could be on our doorstep. That trend is expressly recognized by David Hathaway of NASA's Marshall Space Flight Center during what he believes we can already call the weakest solar activity in hundreds of years. It's not just sunspots, though, and it's not just solar irradiance. This is tough to see, isn't it? And take a look at how 2010 somehow got chopped over all the way on the side next to 1970s, like it's supposed to be there. No, you're supposed to go all the way over to the other side. But anyway, what this was supposed to show is 4 decades of weakening polar magnetic fields on the sun. Now, since that's difficult to describe, I will go back here and describe that when you're looking at that. the heliospheric pressure is lower. This is due to the solar wind being lower. If you watch our channel, you see this often. The solar wind being lower is partially related to the activity of the sunspots. This is also what we track at our channel every single day. The flaring just can't match what we saw at the last cycle maximum. Turns out solar physicists at Lockheed Martin agree. And for those who don't know, those pretty solar images that we saw earlier and the ones that we see in the news every day are processed by the solar physicists at Lockheed Martin, not NASA. They say that it's not just that there are fewer sunspots, but they are less active sunspots. Sunspots going down, solar irradiance going down, flaring going down, and if you could see it, you would know that the polar magnetic fields of the sun are weakening as well. This is partially what's leading to that speculation that we could be coming upon another grand solar minimum. So when you look at all the different ways that the sun changes, you have to take a look at this notion of a solar constant and realize that it's not only relatively inaccurate, but it fails to capture and characterize the solar input only over any relevant time period whatsoever. Now, we also don't have any kind of chart that can account for the lack of major solar flares, the lack of major geomagnetic storms, the lack of major solar energetic particle events. So how do we judge these things? Well, you have to move past that deceptively influential ultraviolet variation, 0.1%, and you have to go to the extreme ultraviolet variation. In just one moment, for those who are unfamiliar with Dr. Tony Phillips, he is a driving force behind interest and awareness of space weather, including its skyrocketing popularity worldwide. Anyway, this extreme ultraviolet radiation variation, try saying that one 5 times fast. It varies most with strong solar activity. So, the lack of strong solar activity now, as the Earth has paused its warming, leaves us missing the high end of our normal energy spectrum. So the highest solar activity in centuries has subsided with signals of going lower, but will we go as low as some predict? Will we enter that grand minimum? It's a paramount question. And when we get to questions like this, I tend to lean on those who have been right so far, those who have seen this coming. These stars that you see here, they represent the range of predictions regarding the maximum strength of the current solar cycle, with the bottom star being that of Arnab Rai Chowdhury. In late 2013, he and fellow scientists published evidence of a grand minimum solar cycle over the past 1,000 sunspot cycles, or approximately 11,000 years. When they ran their model, the dynamo produced between 24 and 30 grand minima over the time frame, between 366 and 450 years apart, according to their best guess models. Now, their best guess based on observational evidence put them right in the middle, 27 grand minima over the 11,000 years, or about 407 years apart, 4 centuries. Coming back for some more context, remember that's important, it's 2014, so 4 centuries ago it was 1614. And if you can find that on the chart, you can see that we may be due for another one, give or take a few decades. Another quote, "It all points to perhaps another little ice age. It seems likely we're going to enter a period of very low solar activity and could mean we're in for very cold winters." That's pretty bold, especially given this alleged consensus on climate change. Where is Dr. Elliott getting his information? Well, in 2013, there was a conference/teleconference in Colorado headed by NASA scientists. If you didn't hear about it, it's because not a single United States news outlet picked up the story. In fact, there was only one article from the Irish Times. It took Ian Elliott and a couple of the other solar scientists who were privy to that information. They put together the article titled "Sun's Bizarre Activity May Trigger a New Ice Age." In that same vein, we've heard that the flaring is going down as the sunspots are going down, and the solar wind is going down, the heliospheric pressure is going down, the polar magnetic fields on the sun are weakening, and as all of these things occur, the heliosphere weakens. The heliosphere is the sun and solar system's version of Earth's magnetosphere, created by the sun, extending out past the planets, and protecting us from galactic cosmic rays. And if we do enter that grand solar minimum here soon, the Earth and all the planets are facing decades of increased levels of cosmic rays. Now, while this is far from settled science, I might suggest an internet search for cosmic rays, global cooling. Now we're going to have to shift gears a little bit, because if this is driven by the sun, and it is truly a solar system shift, we had better see evidence of this everywhere. And we'll start with Venus, where the fastest winds have just gotten 33% faster. Can you imagine F4 and F5 tornadoes are the norm? Category 4 and Category 5 hurricanes and typhoons are the norm. Microbursts and derechos like the one from July 2012 that hit my part of the world in Columbus, Ohio. 10, 15 of them a year? I can't picture it either. Point goes to Venus. Oh, and as Wall told us before, she is spinning slightly slower now. Now, this next one is not new news. It just didn't make big headlines 7 years ago. Up until the time Earth stopped warming so much, it was arguably a tight race between Earth and Mars. Red planet pulling away now. The actual title of NASA's article for this was Big Mystery! Exclamation point. Jupiter loses a stripe. But don't worry, folks. Its meteorological loneliness was abated by Red Jr. We see a lot of storms on Jupiter all the time. We don't usually name them. This was a very, very serious meteorological event. We've also been monitoring the radio output of planets for decades, and Jupiter just decided to start singing a new tune. But if we can come back to storms on gas giants for just a moment, we know all about the predictable 30-year Saturn storm. We know when it's coming. We know how long it's supposed to last. At least we thought we did. It just arrived 10 years early, was much stronger than predictions, and far outlasted all expectations. This would be like the strongest hurricane on record hitting the east coast of the United States on January 31st, and staying there at that strength for 50 days. Point goes to Jupiter and Saturn. So, if we can pull this all together so far, one could make the argument that CO2 and temperature are phenomenally correlated on Earth, unless there's some annoying little species here messing with the balance. And if there is an annoying little species here messing with the balance, according to the scientists at NASA, Johns Hopkins, and the Hebrew University of Jerusalem, the Earth may just have a means of mitigating this nuisance anyway. The sun, much better match for global temperatures over time. The last grand minimum capped off the last mini ice age. Highest solar activity in 400 years during global warming, but it started dropping faster than at any other time in the last 9,000 years. At the same time, the Earth paused its warming. The other planets, they're either proving that climate change is a natural and expected planetary process, or that this shift we're watching now is truly systemic throughout the solar system, leaving only extraplanetary electrical explanations. So, what is happening right now? This is where it gets kind of tricky. The Arctic ice is melting, but at the South Pole they set new high surface ice records almost monthly. One of the coldest winters for many parts of the United States contrasted one of the warmest winters Alaska has ever seen. Parts of South America are genuinely curious as to where their summer went. Most of the rainforest is in drought. Australia is seeing record heat and drought, and parts of Africa are seeing record flooding. Climate extremes of every kind. So that leaves you to ask the question, what's coming next? The planet truly is showing us that we're going to get the kitchen sink. Climate extremes of every kind. And having surveyed just about every argument in this climate change arena, I'm left to put my money on those climate extremes, back and forth, faster and faster, and to greater extremes, first and foremost. But to put me on the spot, force me to choose between one of the extremes as the more likely future that we are going to see here on Earth in the near term, the evidence suggests it's going to be the cold. Whether it's a late frost that destroys states' worth of crops, or whether they're forced to wait months to plant something, if we go into that grand minimum and that pattern begins, it's unlikely to change for decades. Perhaps our current temperature focus requires calibration. Perhaps something is amiss in science. And that notion that something is amiss in science is like second nature to a far larger portion of your professors and publishers than you might imagine. From winning the 2013 Nobel Prize to boycotting major journals. Why? The charge? They obscure the scientific process. They push researchers into popular directions so that they can bolster their own readership and viewership of their own publications. That they have tyrannical publishing rules that restrict the researchers' rights to share their own work. And that they have a host of other issues, including one that has recently led to what is inarguably one of the most embarrassing things in the history of science. A computer program developed at MIT, designed to scour the internet, scholarly articles, and create intelligent-looking papers based on things that look like they should go together. It just randomly scoured and pulled together what the people who made this computer program themselves called gibberish papers. Now, it created literally hundreds of these gibberish papers, and so many of them got published that one of these prankster PhDs at MIT who used a fake name under which to publish got him to be the 21st most cited scientist in the world. That's 15 better than Albert Einstein. He didn't exist. He had no real research. And in fact, that computer program was so far from being ultimately sophisticated that when those prankster PhDs at MIT took a look at what their computers had given them, they said, "This is too unbelievable. This is never going to work. We have to rewrite almost every single abstract." And that they did, but that's all they did, and that's all they needed to get published. There was no real review, nothing. If you'd like to look for this, internet search for journal retracts gibberish papers. You'll find it's not just one journal affected by this. What's the point? Yeah, maybe something is amiss in science. There is plenty of focus on global warming, human emission mitigation, and saving the planet. I wouldn't argue for doing away with those, especially the focus on how humans are poisoning the earth. However, for those who can see the gaps in climate understanding, for those who recognize the misguided current temperature focus, you know the road to revelation may just require gloves and a hat. Path forward is clear. Eyes open, no fear. Thanks, everyone.